Hi, 8th graders. Welcome to the science lab. Some of you have returned to school already, of course, if you're in the hybrid model. But for those of you who are EVA or hybrid at home, here we are back in the lab. Last lesson, you guys spent a lot of time reading, taking some notes, and also filling in a diagram all about this term called groundwater. Water that's found underground. So if you take a look at your page 13, let's just review some of these key things, like big picture here. Remember that the earth is built in many layers over time. And some of these layers can hold water. So we know that layers in the earth that hold water are referred to as aquifers, and that's where the groundwater is stored. We sometimes have layers that are called impermeable layers. Above that, we have saturated zones and even surface water. So there's a lot of connections between all of these different layers here on page 13. And today, what I'm going to do is build these layers in a small container inside a beaker. And then we're going to take a look at how pollution, how when we add a pollutant, how it might work its way down into some of these layers and affect that groundwater. Okay, so let's take a look at the materials I have here, right? I've got tubs of all sorts of different kinds of earth, big rocks, sand, and small rocks. And I even have some impermeable clay. So this is a ball of black clay here, okay? So let's just go ahead and build it. I gotta pull my sleeves up. I'm gonna start by adding some bigger rocks into the bottom of this beaker. Very careful. Okay. So something like that. And then I'm going to add water to this layer of rocks, getting all the way up there. Let's just add a couple more. Try and fill it up there. There we go. I'm going to fill that up with some water, okay? So that is going to be my groundwater. Now I'm going to take this clay, this ball of clay that I've flattened into the disc, and I'm going to put that on top of it as my impermeable layer. And I'm going to push it down in here and seal it against the edges of the beaker here. And what you guys can see is that, oh, I got a little crack here. Hold on, let me fix it. There we go. If I seal it tight against the side, then it's truly impermeable. All right. Next, let's add some sand. Move this over this way. Add a couple scoops of sand as another layer of earth. Ooh, look at that. That's pretty cool. And finally, let me add another layer of rocks. And because earth is not built in perfectly flat layers, of course, you know that from last year, earth science. I'm going to slope these rocks and build sort of like a hill. These are a little smaller. Add a few more. Try and get right up to the top. There we go. All right, now I'm going to add some more water to this, and I'm going to create some surface water here, like a little lake or a pond. Something like that. And I can add a couple more rocks here on the top. And if I keep these rocks on the top dry, that would be my unsaturated zone, right? My dry zone here. So I've got my aquifer with groundwater, my impermeable layer, a layer of sand, another layer of rock, and then a small lake or pond, which is my surface water. Fill it up a little bit more. All right. Now, Let's take a look at page 14. Turn in your INB to page 14. And you can see at the top is titled Lab 15, Aquifer in a Beaker. Well, that's what we just built here, you guys. So please copy the labeling, and you can use color too to help separate out those layers a little more clearly. Copy what you see on the screen right now as those different layers in that diagram on page 14. Now, while you're doing that, Mrs. Von Eschen was supposed to be here helping me with this video, but she got stuck talking about some grammar with Ms. Smith. So I think she should be here in the next segment. I sure hope so. All right, everyone. Next up, we're going to be adding some pollution to our aquifer in a beaker.
Oh, I'm really sorry. I'm late again.
Yeah, that's okay.
So Miss Smith and I were actually having a really interesting discussion about the word groundwater.
Oh.
Is it one word or two words?
Oh.
Right?
Yeah.
It's because I've seen it both ways.
Yeah, in fact, our INB might have it printed both ways too.
Yeah, so I'm not really sure, but...
She didn't have an answer for you?
Not yet. She's going to think about it.
She's going to,
yeah,
okay.
But, yeah, so what's happening? What did I miss?
Well, I'm glad you're here now, but you're going to have to hurry, and I need you to build another aquifer in a beaker. So I just need you to get those layers in there, okay?
Okay, I'll get on it.
All right, show me when you're done.
Okay.
Okay, everybody, while Mrs. Von Eschen is busy building her aquifer since she was running late, we're going to go ahead and add pollutant to our waters. So come on in a little closer. I want to remind you that this water down here, this water is in an aquifer, and this is called groundwater. And this is a really important source of drinking water, or water that we would use for our everyday needs, okay? So when we here up on the surface of the earth are going about our day, doing what we humans do, we want to think about what might be a pollutant that could impact the quality of the water down here in the aquifer. So right now in Minnesota, it's wintertime. It's icy and snowy. And what do we add to our roads to help with the road conditions for drivers and cars? We add a lot of salt, right? Salt would definitely be a pollutant that we don't want in our drinking water source, okay? Other things that we do on the surface of the earth, like when we grow crops, any chemicals we add to crops or to the soil to improve the crops, that can also work its way down into our aquifers and our groundwater source. So in this lab, we're going to use red food coloring as our pollutant, and we're going to see how far down this pollutant goes. And of course, the force that's pulling the pollutant down, right, is gravity. So gravity is going to be pulling this pollutant down through the layers. Let's see what happens. I'm going to add a few drops right here next to our surface water. And even up here in our unsaturated zone, we can add some. All right. And oh my gosh, look at that, you guys. Right away, do you see how it worked its way down through the openings in the rocks, down to this sandy layer? Yeah, look at that. Now that sand doesn't have as many air pockets, so it looks like the pollutant is slower, kind of looks like it stopped moving down there. But if we give it a little time, I think we'll see that it might work its way further down. And if you look at our surface water on the top, see how that pollutant is right there. As I wiggle it a little bit, you can see that pollutant right there already in our surface water. All right, let's check in on Mrs. Von Eschen's. I think she's ready now, and we'll add pollutant to hers as well.
Hi everybody. So I created my aquifer in a beaker too. Now I will say I was doing this very quickly, but I did use all the same materials as Mrs. Anderson. So I've got rocks and water at the bottom. I put some clay and some sand and some rocks again. And I'm going to add some pollution and see if it is going to get through the surface water and through the impermeable layer and get into the groundwater.
Okay, let's check it out.
Let's try it. So here's my lake up here. I'm going to put some right on the edge of the hill where the lake is.
Oh, look at that. Oh, man.
Okay.
Wow.
And then I think I will put some.
That's really cool to see, except when you realize it's pollution.
Yeah, I know it's kind of nasty to think about,
Yeah.
isn't it? Put some on the hill too.
Yeah. Whoa.
See what happens. Now again, this does take time for the infiltration to move that pollution through the layers of the earth.
But look at that, you guys. As I get a little, can you see how that pollutant is starting to work its way down through the sand? Look at that.
Wow.
Kind of slowly,
Yeah.
but it's
It
moving.
is definitely moving. And that's a lot of pollution, so it has nowhere to go but down.
That's right. All right, we'll come back in a sec and check and see how far our pollutants have traveled. All right, now that some time has passed and gravity has been able to do its thing with our pollutant, let's take a closer look at our two different aquifers and see what happened. So we'll come in a little bit closer on this one, and of course you can see right away that surface water, that lake or pond, is definitely polluted, right? But does the pollutant go very deep? Not really. It looks like it gets into a little bit of that sand, but notice it does not make its way through that clay. That impermeable layer is truly impermeable, and the water at the bottom here in the aquifer, so our groundwater in the aquifer, is still clean. So the deeper the water, the cleaner it looks, and the cleaner it is. That's really cool. Let's take a look at this one over here.
Now, this aquifer that I made, the surface water, of course, is really polluted. And then if you look at the sand, which is in the saturated zone above the impermeable layer, it's also very, very polluted.
Yeah, look at that.
So that would be like in the ground. If you were digging, you would see this. And then the impermeable layer didn't keep the pollution from going through into the groundwater. And you can even see little streaks of it going down. And the groundwater in the aquifer is very polluted.
Look at that right there.
Now, in reality, this could be 1,000 feet below the surface. All right, so if this groundwater is 1,000 feet below the ground, then would that be easy to clean once it's polluted?
Yeah, like how would you get that pollutant out of that layer, Mrs. Von Eschen?
I don't know that there is any way
Right.
to get that pollution out. It's just...
So it's probably better to not pollute it in the first place?
I think that's fair to say, because the
Yeah.
other thing is this impermeable layer. When I built it really fast. And so it's likely that it had cracks in it or gaps between the edge of the glass here. But in reality, that's the Earth's layers. They're not perfect. So there are going to be gaps and cracks in it where water and pollution can leak through and get in to that aquifer. So that resulted in very polluted groundwater.
Yeah, that's a really good point.
Now use that information, everyone, to answer the questions on page 15, where you're going to answer what if the groundwater was polluted, which it was in the one that I built. And then if the groundwater was not polluted, use that information from the Mrs. Anderson's Aquifer in a Beaker to answer the other 3 questions.
Yeah. All right. Thanks for watching, you guys. If you have questions on this, of course, ask your teacher. Thanks for watching.
Bye.